This is lesson 9.4 on direct variation. So in words, this key concept is a direct variation is a relationship in which the ratio of y to x is a constant m. We say y varies directly with x. So to find the m, or the slope, or the constant of variation, you take y divided by x. The general form of direct variation is in this form here, y equals m, which represents a number, times x. So an example would be y equals 2x. 2 would be your slope, or the constant. Non-examples are like y equals 4x plus 6, or x minus 12. They have another part after the x part. So those are two non-examples. So when a ratio of two variable quantities is constant, their relationship is a direct variation. Since the point 0, 0 is a solution, the graph passes through the origin and represents a proportional linear relationship. So remember, linear makes a line and it has to go through the origin. We also talked about m is the constant of variation, or the constant of proportionality, and it's another name for it is the slope. So let's look at an example. Example 1, we have trail mix here. As the weight increases, so does the cost, so it is directly proportional. It starts at the origin and is straight, so we just have to check to make sure the constants are the same. So the three things you're checking for: number 1, does it pass through the origin? Number 2, is it a straight line? And number 3, are the constants equal? So those are your three questions. So we already know it goes through the origin and it's straight. So the constant, we find the constant by taking the cost, or the y value, divided by the weight, or the x value, for each point on the graph. So this is our y, this is the x. So this first ordered pair here is located at 4 for the weight and 14 for the cost. So my first point, my cost was $14 divided by 4 pounds. And if I divide 14 by 4, I get 3.5. In money, that's $3.50 per pound. So that's the first point. The second point is located right here, and that is 8,28. So for $28, it was an 8-pound bag. So if you divide those out, you again get $3. $3.50 per pound. So far these are equal. So we have one more to test. The third point right here is 12,42. So for $42, you get a 12-pound bag. If you divide those again, you get $3.50 per bag, or per pound. So all your constants are equal. It went straight through the origin, and so this is a yes. This does display a direct variation equation. All right, so here's another example. If you are burning a CD, different amounts to a CD, it varies directly with the time. So if you think about this, the more megabytes that you have, the longer it's going to take for the CD to burn. So those, as one increases, the other increases. So those are directly related. So we need to write an equation to find how long it will take to fill a 700 megabyte CD. So we're going to use the three-step process. Step 1, use the equation y equals mx. So that is the general direct variation equation. Choose any point on the graph. So let's choose this point here, 10,40. 10 represents the x value, and y is the 40. So I'm going to replace what I know. I know y is 40. I don't know the m, but I know x is 10. Divide both sides by 10, and you get the constant is 4. So to write my variation equation, you're just replacing the m with 4. So in general, y equals 4 times x. Now, why am I writing an equation? Well, I want a 700 megabyte CD. And if you notice, the graph only goes to 30. So if I continue this till 700, it's going to take quite a while to extend the graph. So if we write an equation, we can ignore the graph and just use my equation to figure out any type of megabytes CD, how long it's going to take. So since my megabytes are down at the bottom, this represents the x value. So that means I'm going to replace, in my y equals 4x problem, I'm going to replace that x with 700, which is y equals 2,800. So how long is this going to take? It's going to take 2,800, and make sure you label it. The time is in seconds. So this is your final answer. And I could use that same equation. Say I wanted 500 megabyte CD. That would be 4 times 500. If I want 100, I would replace the x with 100, and it would be 400 seconds. So you could use that equation for any amount of megabytes. And lastly, we can compare to direct variation. So this graph on the right talks about a cat's heartbeat. And I know some information about the time and the number of heartbeats. The equation y equals 1.5x represents the relationship between the heartbeats, which is y, and the x represents the time in seconds for a dog. So they give us the equation for the dog, but the graph for the cat. So from the dog's equation, you can figure out the dog's heartbeat per second. And that is just your number, the constant in the center. So the dog's heartbeat is 1.5 beats per second. Okay. The cat's heartbeat, we have to do some math for. So we can take the y value, divide it by the x for all the ordered pairs on the graph. So 1, 2, the 2 is the y and the 1 is the x. So that would be 2 divided by 1, or just 2. The second point would be 4 divided by 2, which is also 2. Third point is 6 divided by 3, which is 2. And last, 8 divided by 4, which is 2. So that means the cat's heartbeat is 2 beats per second. So if we go back to the question, which animal has the faster heart rate? Well, I know 2 is bigger than 1.5, so the answer is the cat. It has a quicker heartbeat. All right, so that is the end of direct variation. The key concepts are it has to be in the y equals mx form to be a direct variation. To find the constant m, you take the y value divided by the x value. And always make sure you have labels on your answers.